Imagine pointing the most powerful telescope ever built deep into the cosmos and finding what looks like a gigantic wall. A wall made not of stone or metal, but of galaxies. Billions of them, lined up across space in a structure so vast it shouldn't even exist. This isn't science fiction. This is real data from the James Webb Space Telescope. Scientists are staring at something they don't fully understand, a cosmic wall that stretches across the early universe. But here's the question: what is this wall? Why is it there? And what could possibly be hiding beyond it? Let's take a journey into one of the most baffling discoveries of modern astronomy, the universe's new mystery wall. Astronomers have always known the universe is not random. Galaxies don't just float around evenly spread out. They gather in clusters. Clusters link together in long chains, forming what we call filaments. And those filaments weave a giant pattern across the cosmos, something scientists nickname the cosmic web. But even within this web, there are limits. Structures can only be so big. The rules of physics and time mean you shouldn't see something larger than a few 100 million light years across, especially not in the young universe. And yet, that's exactly what Webb has revealed. When researchers studied a patch of deep space with JWST, they noticed something odd. Instead of galaxies spread smoothly across the image, they appeared to be clumped, lined up, almost like a wall stretching across cosmic distance. This cosmic wall isn't solid, of course. It's not blocking anything. It's more like a vast sheet of galaxies all aligned in one direction. But the sheer scale of it is staggering. We're talking hundreds of millions, maybe billions, of light years across. A structure so large that it dwarfs galaxy clusters and superclusters we thought were the largest things in the universe. The scientific community reacted with amazement. Some called it impossible. Others said it's a challenge to everything we thought we knew about how the universe builds itself. And the public? Equally stunned. A wall of galaxies sounds like something out of a sci-fi movie. But this is real astronomy. So how exactly did Webb see something so far away? How Webb looked that far? The James Webb Space Telescope is unlike any telescope before it. What makes it special is its ability to see in infrared light. Why does that matter? Because the universe is expanding. The farther away a galaxy is, the faster it's moving away from us, and its light is stretched, shifted into the infrared. That means by the time it reaches us, billions of years later, it's invisible to the human eye and to normal telescopes. Webb changes that. Its instruments are designed to capture this faint, stretched light. So when Webb stares at a tiny patch of sky for hours or even days, it gathers enough photons, tiny bits of light, to build a picture. And in those pictures, astronomers saw this wall-like alignment. Let's pause here and try to visualize the scale. The Milky Way, our home galaxy, is about 100,000 light-years across. That's huge. But this cosmic wall is millions of times larger. Imagine stacking millions of Milky Ways side by side, and you're still not covering the distance Webb captured. It's so vast that even light, the fastest thing in the universe, would take hundreds of millions of years to travel across it. The techniques used to reveal this wall are also mind-blowing. Astronomers don't just look at a picture and say, "Oh, there's a wall." They run the data through complex models, checking distances, redshifts, and brightness. They separate galaxies that only look close together from those that actually are. What remains is a map, and on that map, you can trace a line, a wall, a structure too massive to be ignored. And this brings us to the big questions and theories. Why is this cosmic wall here? And how could it form so early in the universe's history? Right now, scientists don't have a final answer, but here are the leading ideas. Hypothesis 1. Cosmic filaments. The universe is filled with filaments, those long strands of galaxies connected by gravity and dark matter. Maybe this wall is just an unusually large filament, stretched farther than we expected. Hypothesis 2. A cosmic coincidence. It's possible this isn't one continuous wall at all. Maybe it's galaxies in different regions of space that, from our perspective, just happen to line up. Think of standing in a forest. The trees look like they form a wall, but they're actually spread out at different distances. Hypothesis 3. Something new. And here's the exciting one. Maybe the wall is telling us our models of the universe are incomplete. Maybe dark matter behaves differently than we thought. Or maybe new physics is hiding in plain sight. What's important to understand is that this isn't a barrier. Some people imagine a cosmic wall as the edge of the universe. That's not what this is. The universe doesn't suddenly stop there. It's just a massive, surprising arrangement of galaxies. Still, its existence creates tension, because in our current models, such a structure shouldn't have had time to form. Gravity needs billions of years to pull galaxies together on this scale. But Webb is seeing this wall at a time when when the universe was still young. This is why astronomers are scratching their heads. It's like finding a fully grown tree in a forest that was planted just a few years ago. Something doesn't add up. So if this wall exists, what's beyond it? Beyond the wall, what could be hidden? This is where imagination and science meet. If there is a cosmic wall, what's on the other side? One possibility: even more galaxies. Behind the wall might lie the earliest galaxies ever formed, faint, primeval structures from the dawn of time. Another possibility: clues about dark matter. We know most of the universe is made of this invisible substance, shaping the cosmic web. If the wall is thicker or denser than expected, maybe it's revealing how dark matter clumps together. Some astronomers even speculate about new physics. Perhaps the rules we use to describe the universe, general relativity, dark energy, cosmic inflation, need tweaking. Discoveries like this are where revolutions in science often begin. And of course, there's always the human fascination with mystery. A cosmic wall feels like a boundary, a curtain, and beyond every curtain is the unknown. Could we find the very first stars? Could we glimpse the cosmic dawn, when light first broke through the darkness after the Big Bang? That's what astronomers are hoping. The future of cosmic exploration. So what happens now? Webb won't stop here. Astronomers will keep mapping this region, taking longer exposures and measuring the distances of more galaxies. The more data they gather, the clearer the picture becomes. Other telescopes will help too. The Nancy Grace Roman Space Telescope, launching later this decade, will have a much wider field of view. It will be able to scan huge swaths of the sky, revealing whether this wall is unique or just one of many. Ground-based observatories, like the Vera Rubin Observatory in Chile, will also contribute. By combining data from multiple telescopes, scientists can build a 3D map of the cosmos. And that's when we'll really know, is this wall a one-off anomaly or part of a bigger pattern? For now, though, the discovery pushes the limits of what we thought was possible. It redefines how big structures can be. It challenges our understanding of time, gravity, and cosmic growth. Most of all, it reminds us how much mystery is still out there. Because every time we think we've reached the edge of knowledge, the universe throws us something new. So the next time you look up at the night sky, remember this. Somewhere out there, beyond the reach of our eyes, a wall of galaxies stretches across space. A wall so vast it bends our imagination. A wall that shouldn't exist, but does. And behind it, the unknown. That's the beauty of science. Every discovery is not an ending, but a doorway. The James Webb Space Telescope is only beginning its mission. And with every image, every faint flicker of light, it's showing us that the universe is stranger, bigger, and more mysterious than we ever dreamed. Stay curious, because the story of the cosmos is just getting started.